All right, so a geometric sequence and series are what we're going to talk about today. So like the arithmetic where you have this common difference that's being added or subtracted each time, in a geometric sequence you have a common ratio that's being multiplied by those terms each time. So you can find that common ratio by taking consecutive terms and dividing them. Okay, so you can see here, you know, if you take 4 divided by 2, you get 2. 8 divided by 4, you get 2. 16 divided by 8, you get 2. So the common ratio there would be 2. If you take a look at like n and n squared again, this doesn't work. 4 divided by 1 is 4, and then 9 divided by 4 is 9/4. So we don't see that common ratio. So you find it the same way you find the common difference. Okay? The nth term, okay, is going to be this pattern right here. So geometric sequences follow the pattern basically of an exponential function, right? So we know that an exponential function looks like y equals a times b to the x, okay? Well, this is the same type of pattern. A sub 1 is your first term, and then r is that common ratio. Okay, notice that r is raised to the power of n minus 1. Okay, so we want to memorize this. Don't worry about this. Alright, so far so good? Alright, so we're going to look at the pattern of like an exponential function where arithmetic looks at a pattern of a linear function. Okay? Write the first 5 terms in the geometric sequence whose first term is 5 and whose common ratio is 3. So this is pretty easy. That first term is 5, they're telling you, and then the common ratio is 3. So the common ratio means that r equals 3. All you have to do is really multiply the previous term by 3, but what's happening there, if you think about the pattern, or the nth term, a sub n is equal to the first term times r, which is 3, raised to the n minus 1 power. So if I was thinking about the second term, I'm going to have 5 times 3 to the 2 minus 1, right, which is like really like saying 5 times 3 to the first power, which is 15, which you'll notice I could have just taken the first term and multiplied it by 3 to get there. Okay? This is the nth term's pattern, and then we just need those first 5 terms. So we're just going to cut the corners, right, not fill in all the stuff and just multiply by 3. So 45. The fourth term is 135. The fifth term is 405. Each time just multiplying by 3. So this is like 5 times 3 squared, 5 times 3 cubed, 5 times 3 to the 4th. Everybody see the pattern? Okay, everyone all right? Okay, find the 12th term of the geometric sequence whose first term is 8 and r is 6.2. So they're giving you all the information you need in order to figure out the formula. Okay, so let's write the formula. So I have the first term is 8 and I know r is 6.2, which are the 2 pieces of information I need to write an exponential function or a geometric sequence. You know what I just noticed? This is arithmetic right here. And it's not. This is geometric. Right. Okay, so the nth term is going to be a sub n equals that first term 8 times the common ratio 6.2, which is our r value, raised to the n minus 1 power. So if I'm trying to find the 12th term, don't I just have to plug in 12 for n? So a sub 12 is going to be 8 times 6.2 raised to the 12 minus 1. This is going to give you a very large number. Ready? When you plug this into the calculator, you know, you can either put parentheses around the 6.2 or just, you know, make sure you multiply. Don't just type in 86.2. Okay, so a sub 12 is, let's see, 4,162,000,000 924,855. Okay? Good thing they didn't ask for like the 20th term. Right? Yes?
In this equation, should we treat a sub 1 like a sub b?
A sub b.
Like in the last sentence we did?
No, you need the first term for the geometric sequence. So, yes, it is, because I think we called a sub b the first term, but that didn't have to necessarily be a sub 1. Okay? Find a formula for the nth term of the following geometric sequence, and then what is the 7th term? So we need two things in order to find the nth term, right? We need the first term, and we need r. So we need a sub 1, and we need r. Do we have a sub 1? Yes, what is it? Good. How do I find r? Yeah, just divide two consecutive terms. So 36 divided by 3 is going to give me 12. Okay, so now if I'm going to write the nth term, I just have to plug in those pieces. So I'm going to have 3 times 12 to the n minus 1. Okay, if I want to find the 7th term, what do I need to do? Plug in 7 for n. So a sub 7 equals 3 times 12 to the 7 minus 1. And let's see, do I have that somewhere? Yeah. 8,957,952. I'm assuming that you're comfortable entering these into your calculator. Is that a fair assumption? Okay. All right. The first term is 5, and the third term is 45 over 4 of a geometric sequence. Find the 8th term. All right, well, I kind of have to do the same thing I've been doing, right? I need the first term, and I need an r value. So I want you to think about this one now. So we have a sub 1 is 5, and we have a sub 3 this time, which is 45 over 4. I am looking for a sub 8. So really, anytime you're going to look for a term, you really need a sub n, so you can substitute it in, right? So I need a sub n, and I know that a sub n has to be the first term times r raised to the n minus 1. What I don't know is r yet. So my question to you is, how am I going to find it? Ryan?
45 over 4 subtracted by 5 divided by 2.
You can't do that here. You can't do it like the arithmetic one, because it's not a total being added. It's something that's being multiplied. Okay? Any other thoughts? Paige?
I plugged in the third term for so I did 45 over 4 equals 5r 3 minus 2 minus 1.
So you really treated it like the a sub n formula, right? And you plugged it in because you know some information here. You know another term. So it's almost acting like an ordered pair. Think about it. Like if we were going to plug in an x and a y to minimize our variables. Okay? So this is now going to be a sub 1 times r, but now n is going to be 3 because I had my third term here. See what we did there? Okay. Remember, the a sub n formula is the first term times r to the n minus 1. So that's why I'm minimizing those variables there, being able to solve for r. So now what do you have to do to solve for r? Either divide by 5 or multiply by a fifth, your choice. Okay, if I multiply by a fifth, I get 45 over 20 equals r squared. And then you can simplify this, which I would, starting out. You get 9/4 because it makes it a little bit easier to take the square root. Everyone agree you have to take the square root in order to solve for r? Okay, now r is going to give us 3 over 2. Yeah. Okay, so now I'm going to plug it in, right? Because now I can find my a sub n rule. So now I know my common ratio is 3 over 2, and I have n minus 1 there. So when they ask me to find the 8th term, I'm now able to do that. So a sub 8 is going to be 5 times 3 halves raised to the 8 minus 1. Now be careful when you are entering this into the calculator, because you want to put parentheses around this 3/2. All right, so that way it makes the whole thing is our common ratio being raised to the power of 7. Okay, so just be careful there. Let's see, the 8th term is 10,935 divided by 128. These questions were all pretty similar. Does anyone have any questions on either how to find R, the first term, how to use the formula? Excellent. Okay, it's time to talk about sums. Are you noticing the pattern how we do things around here, right, in this unit? Okay, so now we're going to talk about the sum of a finite geometric sequence, which means there's a set number of terms we're trying to add together, right? So that's what that finite means. All right, so now the piece that I really need you to pay attention to is this one right here. Okay, this is what we want to memorize. I want you to make, though, a special note here. So whatever your first term is, the a sub 1. Okay, so your first term represents a sub 1 in this formula. Okay, now the thing is it could be the 0 term. Or it could truly be the first term. Okay, so don't get hung up on that. This a sub 1 is going to act like that a sub b that we talked about yesterday. All right, whatever the first term is, that's what you're plugging in there. Okay, so let's take a look at one of these. They want us to find the sum of this geometric sequence. Yes? You'd have to find a sub 1 unless this started at 3.
Yeah.
Yes, then you could.
Okay.
Okay, so now here we have a lower bound of 1, an upper bound of 9. Okay, now this is a geometric sequence. You should be able to recognize it. It's in the form, right? What is the first term? 1. Why is it 1? Because there's like a 1 times that negative 2 to the n minus 1, correct? Right, we just don't look at it that way. Right, we don't write it. But the first term here is 1. So now I have a sub 1, okay, which I need for my formula. I need a sub 1, I need r, and I need n. So as long as I have those pieces, I can go right into the formula. So a sub 1 is 1. What is r? Good, negative 2. And then n in this case is 9, right? There's 9 terms from 1 to 9, so 9 terms. So I have n, I have r, I have a sub 1. I'm ready to just substitute. So a sub 1 is 1 times 1 minus r to the 9th power divided by 1 minus r. Now this one, I do want you to take the time to plug into your calculator because this one's a little bit harder, more complex to plug in. So practice. You should get 171. So make sure you can get that, because again, this does become a little bit more complicated to plug in. Does anyone need help with their calculator? Moving on. Need a minute more? No problem. Yeah. Ooh, spooky. Yeah, because, yeah, you can't distribute that power. That's nature illegal. Like you have, let's see. So it's 1 minus 2.
See, it's so
Spooky.
bad.
It's so spooky.
I have the two.
You got it too, maybe maybe I typed it in wrong.
I got 171. I got
You
it.
did?
What the heck? I spent.
I did it. I did it.
Oh, I know what you did. We didn't put parentheses in the numerator. I hate your calculator. Let's see.
Sorry.
Oh my God, how did you get out of the screen? Could have paused the video. Okay, so let's do 1, press 1 minus -2. If you're getting a 0.667 after the 171, it's because you did not put parentheses around your numerator. So you need to put a set of parentheses right here. Okay, so if you are not getting 171 even, that is why. Now, in future problems, it'll throw it off more. It's just because we have all these like special ones going on here, right? So make sure you have that. Okay, so can you get 171 even? Okay, all right, I'm going to move on now. Okay, all right, so sometimes there is this special case, and it does not start with I equals 1, and instead it starts with the 0 term. Now, there is a very complicated way to do this problem, but there is a much easier way to do this problem, and that's what I think we should do, okay? So, let's think about this. A sub 1 is your first term. Can't we see the first term here? It's 2. R, we can also see, is 4/3. Now, before, n was 9, right? But now I have to start at 0. So if I was starting at 1, I would have 15 terms here, right? But now instead of 15 terms, I need to find the sum of the first 16 terms. I have one extra term here. So make yourself a note. This n equals 0 here is a special case, all right? And you need to make an adjustment to the formula. So this adds an extra term. The easiest way to deal with this is just to count it as an extra term. So instead of having 15 terms, we now have n equals 16 terms. Does that make sense? Okay, it's a simple adjustment. So now let's just plug it in. So now we're going to have our first term, a sub 1, which is 2, times, let's put those extra parentheses here so you don't forget them when you're putting them in the calculator. 1 minus r, so 4/3 raised to the n, so the 16th power now, close that set of parentheses, divided by 1 minus r. I want you to put this one into the calculator because, again, this is a more complicated formula. Put an additional set of parentheses in your denominator if you're not going to enter it in as one term. Okay? Yeah?
So the I is equal to 1, the value on the top goes.
Right.
So then yesterday we went to
You're still really subtracting and adding 1.
okay.
Because here I'm really doing the same thing. 15 minus 0, and then I add 1. It's the same deal.
Okay.
Yeah. Okay, we should get the sum of those 16 terms is 592.647. How'd you do? Better this time? Okay. All right, one more thing. 592.647. Okay, so the next thing we have to talk about is the sum of an infinite geometric sequence. So the only difference here is now we're going to infinity. There's not a set number of terms, okay? That is going to follow this formula here. A sub 1 divided by 1 minus r. I hope you understand that anything that I'm highlighting today you have to memorize, okay? So, to find the sum of the infinite series, you just gather your information and plug it in. So I need a sub 1, which, can I see that from my formula? Yep, is 6. And I need r, which is 2/3. And then I plug it in.
Do you know exactly, so because it's a form, that's how we always find
Remember that r could be, it could also be greater than 1.
it says that right?
If the absolute value of r is greater than 1, yeah, so it's going to be positive. All right, so here we're going to have the first term 6 divided by 1 minus 2/3. This one we can just do in our head. So 6 divided by 1/3, we get 18. Okay. This one's a little different, right? Yeah. Because we're going to infinity this time instead of a set number of terms. Oh, you're saying why isn't the answer infinity? Oh, because it's gonna approach a solution. It's gonna like approach. Remember, like on our graphs where we had like those rational functions and we had asymptotes and we would approach a particular value. It's kind of the same idea. Okay, so here, what do we have to do? It's different, right? Because it's not in this summation notation. So now we have the list of terms, but you only need 2 pieces of information. You need the first term, and you need what? R. So what's the first term? 8. And how do you find R? 6 divided by 8. So 3/4. So I'm going to have 8 divided by 1 minus 3/4. So 8 divided by 1/4, I get 32. This one's easier, right? Easier formula. Okay. You know everything that is going to be on the quiz now for Tuesday, 8-1 to 8-3.